Hello, hey.
Yeah, welcome back to our hands-on AI, where we walk you through step by step for AI practical labs. I'm Annie.
And I'm Ayo.
Yeah, so for this is two-part episode series. So for yesterday, it's a part one that we went through everything from MCP server to ADK agents and workflow ADK agents. And if you're interested in that part, making sure you check day one, like yesterday's content. And today's content, we're gonna talk about agent to agent protocol.
Yep.
IO.
Yeah, so today we're going to be covering A2A, agent state and memory. So it's a
Yeah.
jam-packed session. So let's dive into it. So I'm going to go
Yeah.
ahead and share my
Before
screen.
we dive deep into it, if you're missing yesterday part, making sure you check yesterday part because you need to claim your credit there and also need to do the setup there. So you can listen to today's episode. However, if you really want to do things step by step and make the demo work on your machine, making sure to check yesterday's replay. And yeah, I will. Please
Exactly.
take over.
Yeah.
Yeah.
So everything that Annie just said, but I'll go ahead and share my screen, and then we'll
Okay.
deep dive through the architecture that we're building today.
Okay, let's start.
So you should be able to see my screen now. So yesterday, what we did was
Mhm.
deploy three separate workflow agents: one for the fire familiar sequential agent, one for the water familiar
Yep.
parallel agent, and one for the earth familiar loop agent. And they're all being coordinated by the summoner agent. That's essentially the orchestrator in this particular workflow. But that works really well for
Yeah.
the most part. But you can imagine use cases where, let's say, the summoner is being deployed as a separate microservice on a separate endpoint or app, and then
Yeah.
each of these individual familiar agents are being deployed on their own service as well. For those use cases where you have remote agents communicating with each other, you need some sort of protocol that kind of enables that, and that's where agent to agent protocol comes in, or A2A.
Yeah.
A2A is essentially it equips each agent with its own resume and makes it discoverable by other agents. So
Okay.
agent card, yeah. So when I say agent card, what comes to mind, Andy?
Yeah, it's like a name card. Like when I first time I meet you, I'm gonna say, "Hey, this is my name card. This is what I'm good at. This is what I can offer and how you can contact me."
Exactly.
Right?
Yeah. So each agent card, which is essentially a discoverable JSON at a well-known path for each agent at the deployed endpoint for each agent, essentially the capabilities of that agent, the skills, and it also something for it's important for authorization and security is how can you authenticate with that agent. So you may not want anyone to be able to call that agent. A2A actually enables what you call security schemes, where I can set API keys or other OAuth mechanisms where only the personnel that I want to authenticate against that agent authenticates.
Yeah.
So essentially, that's A2A. So again, what A2A is facilitating behind the scenes is each agent has their own agent card, and that's initialized and made available by the server.
Okay, so it's like I have many agent there. They all say, "Oh, here's my name card. You can get to know what I'm good at, how to contact me, so that the client side, the workflow agent, can first understand, okay, what are the available agent in this space, and then read
Exactly.
their name card and
Exactly.
decide, okay, who I want to contact to, and then how do I contact them."
Exactly. Yes, and that's you pretty
Yeah,
much just covered client discovery. Then essentially that root agent, or essentially the consumer of those root agents, essentially discovers all available agents by retrieving their stored agent cards and
yeah,
essentially looking at the descriptions of what each agent can do and its skills.
yeah,
And then finally, as part of the runtime of the agent, as the coordinator runs into a use case, it may call one agent or invoke it based off of the instructions and based off of the description of the agent. So it's going to kind of do semantic selection of what agent is best to use for a particular use case. But overall, it's the same exact concepts of what we learned for the local agent, but all
yeah,
essentially we're using A2A to kind of facilitate the remote agent approach, where essentially agents can now be discovered across different endpoints. So
yeah.
now going back to the lab, so now that we've kind of covered a little bit of the architecture, now we're actually going to go ahead and actually build that through code. Essentially, we're going to enable each of those familiar agents with their own A2A endpoint that
Yeah.
essentially makes available agent card.
Maybe we should give our audience an overview of what is the theme for this collab or for this lab. So in case they're just first time dining in, like they're confused, okay, why there's a magician there holding a fire, right?
Oh yeah. So for those of you that are just tuning in for the first time for day two, as Annie mentioned, if it's really important that you kind of go through day one first. We kind of walk through a lot of the environmental setup as well as the context of the lab. But just on to do a quick recap, essentially
Yeah.
for this lab, we are building a summoner agent that at the end is going to fight a boss.
Yeah, we're gonna fight a boss.
And that boss is essentially another agent. So that monster that we're fighting is actually an agent that's going to communicate with our summoner agent via A2A. So
Yeah.
essentially A2A is embedded all throughout the slab. So overall, what we want to do first is kind of equip our summoner agent with all the tools and agents that it needs. So that's
Yeah.
the process that we're going through right now. So that said, as mentioned before, what we're going to do now is essentially
Yeah.
enable each of our familiar agents, fire, water, and earth, with their own A2A endpoint. So essentially, it can
Okay.
be exposed as its own endpoint and then consumed later on by the summoner agent. So
Yeah,
let's
so
go ahead and do
someone
that.
can later on contact them through that URL.
Yeah.
Even though they're deployed, they can connect. Oh, I'm curious when you do. Oh, I think you're not sharing your screen for your Cloud Shell.
Yeah, I'm not in the call stream yet. I just wanted to first
Okay,
walk you through the
great.
code. Yeah, so here's where we should be in the collabs to make sure that you are at step number 6. That's where we are. And then
Mhm.
what we're now going to do is very simple. You're going to see
Mhm.
that the syntax that we're going to add is no more than a few lines of code, but from
Mhm.
agent to A2A, import to A2A. And then essentially all we're going to do is grab that agent, variable name,
Mhm.
pass it into the essentially imported function to A2A. Essentially, what this is going to do behind the scenes is make sure that endpoint has the agent card at the well-known path,
Yeah.
and that's pretty much it. And then at first, we're going to test it and run it locally. Then later on, we're going to deploy each of these agents to Cloud Run, and then essentially have them each running on their own Cloud Run endpoint. Let's go
Yeah,
ahead and
let's
do
do
that.
it. Let's do it.
Yeah. So essentially, this is where we left off yesterday.
Zoom in,
I'm
zoom
going to
in,
go
zoom
ahead and
in.
clear my terminal. And again,
Zoom in.
we're going to be opening up the editor for this particular exercise.
Okay. I'm curious. When we say we have an agent card, right? How do we get those information? Like you mentioned about the agent skill, what this agent can do. How does the agent card understand? Like having those related information has a good summary of what this agent can do.
That's a great question. Okay. So as Annie mentioned earlier, when we were building out the agents earlier,
Mhm.
all those criteria that you add to the LM agent, such as the name, the
Name.
description, the instructions, these all essentially via the to A2A function, these are converted into A2A compatible specs or the agent card that
Yeah.
other agents can consume. So it's also really important as an engineer that when you are defining these agents, you're being very clear when it
Oh,
comes to the description and what it's
maybe we
meant to
can
do.
give an example. Maybe you can go to a fire agent and show us the fire agent. Like what does it look like?
Oh yeah, great question. So great point. Yeah,
Like
so
go
this,
to. Mhm.
yeah, so great
Please.
point. So this is the fire agent that we built out yesterday. So we have the scout agent, if you recall, and then the amplifier agent and the sequential agent path. So you can see that we're being very detailed. We're giving it instruction. We're giving it a very clear name. These are all translated into the actual kind of specs that appear in the agent card later on. And we'll actually take a look at an example agent card by calling in the endpoint of one of these models, one of these remote agents later on. But essentially, that's what you want to make sure is very clear as part of your definition. But
Yeah,
already,
that's.
yeah,
Sorry. That's. Yeah, sorry to interrupt. Please go ahead.
yeah. But as mentioned before, we're only going to be adding a few lines of code, and that's kind of the power of the ADK and its integration with A2A. Again, all we're going to do is import the to A2A package,
Yeah.
and then we're going to be using UVcorn as essentially like a development runtime server, so we can test it locally and run the app. But
Yeah.
that's pretty much it. So all we're doing is converting this root agent to A2A, and that's it. And again, it's going to be running port 8080. Okay, moving on. We're not going to do the same exact things through all our familiar agents. So we just did fire. Let's go ahead and do earth. So again, I'm going to go over here to the agent.py file. I'm going to scroll all the way down. We can see all the previous code that we entered yesterday. Now I'm going to do the same thing. All I'm doing essentially is taking that root agent, which is essentially the loop agent for earth, for example, and then I'm
Yeah.
passing it into the 2A2A function,
Yeah.
specifying the port, the public URL, and the UVcorn run, and that's pretty much it. And
Yeah, so that the client side, when we discover them, they can have this URL and discover those agent from the
exactly,
server side, right?
exactly. Yep. Yeah. So that's pretty much it. And then now I'm going to do the final thing with the water agent. So we just edited the fire agent, the earth agent, and let's make sure that we update the water agent as well. I'm
Sure.
going to scroll down here. And again, we can see all the previous subagents that were defined for the water agent. We can see the, again, root agent definition, which is a sequential agent for water. But then
Mm-hmm.
we're just going to do the same thing here where we say from agent to A2A, import to A2A.
Yeah.
We are going to pass in the root agent. And again, that's pretty much it. It's really simple
Yeah.
to essentially enable your agents that are defined with ADK for A2A. So
Yeah.
now
So
that we,
now they can all have this URL. That's yeah.
yeah, yeah.
That's
Okay, so
discoverable. Yeah.
So
Please.
now what we've done is define this code locally for all three of our sub
Uh-huh.
familiar agents. And now what we're going to do is now essentially deploy each of these familiar agents to the cloud. So they each have their own A2A endpoint. So one will have its own cloud run service, the fire have its own
Yeah.
cloud run service, water own cloud run service. Same thing with
Yeah.
the earth. So I'm going to go ahead and run this here. And if you recall, we talked about Cloud Build before. Again, Cloud Build is like the CI/CD engine for Google Cloud Services on Google Cloud. You can use it to automate different build steps. So that's what we're going to do here. And we'll take a look at the Cloud Build file as well. So I'm
Okay.
going to go ahead and
Let's
save
see.
this.
What does the file look like?
Yeah, yeah.
Let's,
So here's what the fire
oh,
looks like.
did you paste to the terminal?
I haven't pasted it yet, but
Oh,
I just
okay.
wanted to kind of show you what it looks like. So
Sure.
it's gonna take a few, maybe 2 to 3 minutes. But the reason why it's taking a little bit of time, you can see we're automating a lot of steps behind the scenes. We're building the familiar image simultaneously. We're storing the artifact in artifact registry, and then we're deploying the three services in parallel. We're deploying each of the familiars to their own Cloud Run service, and that's pretty much it. So there's 3 steps or 3 to 4 steps being automated, depending on how you count. So now that we know that, let's go ahead and it looks like my screen froze. So I'm going to go ahead and refresh.
Sure. Yeah, it happens sometimes on Cloud Shell.
Yeah. Okay. So we know what the
Oh,
Cloud Build YAML is doing. So going back
yeah.
here to the terminal, I'm going to zoom in so
Don't
you can see
forget
very
to zoom
closely.
in. Yay.
And so again, I'm just going to be running that Google Cloud Build submit Cloud Build that YAML file. So essentially, it's building the container image behind the scenes, and also we have a little bit of other environmental things that are part of the code lab. So essentially, we just want to make sure that your environment has all the variables that it needs, such as the DB name and username for the toolbox that we defined earlier. Right now, you notice that the fire URL, water URL, and earth URL is still blank. That's what we expect. We haven't deployed anything yet. But later on, when we actually take a look at these variable names, they're going to have each their own, essentially, Cloud Run service endpoint. But overall, so everything is running so far. And let's go ahead and see how things go. So again, this will
Yeah,
take 2 minutes. Yeah.
I am curious about the reading. So you said that A2A that allow agent to agent communication, right? What if I deploy one thing on Cloud Run, another agent maybe at a different like place, like for example GKE or like different cloud, a different like maybe agent engine, like can I still using A2A to connect?
Oh, great question. So the nice thing about A2A is it's a universal protocol for agents that are not only built with ADK. You can build your agents with Crew AI, LangGraph. These are other popular agentic frameworks. As long as, again, you're deploying with A2A compatibility, which means your agents have a well-defined agent spec or agent card. Essentially, you can build your agents with any agentic platform and still leverage A2A. So that said, it doesn't also matter where your agents are deployed. You can have your agents deployed locally or on premise, which is the same thing, or on the cloud, such as GKE or Cloud Run. Again, as long as they all are complying with A2A spec, they can communicate with each other. So you tend to see use cases, for example, like an on-device agent. Let's say I have a agent that's running locally. I wanted to be able to access my private data, but I don't want cloud agents to be able to do so. Oftentimes, you see people running agents locally and then communicating with their agents on the cloud through A2A. So that's just one example.
Oh, that's really cool. But I also heard a lot of people are asking me, oh, can they just use MCP? What's the difference between MCP and A2A?
That's a really great question. And I actually have a slide for that as well.
Oh, can we see that?
Oftentimes people wonder if A2A is competitive with MCP or is it collaborative. I like
Oh.
to look at it as a collaborative kind of aspect where A2A is really good for enabling agent to agent communication, where MCP
Uh-huh.
essentially enables tool discovery and tool communication with your agents. So think
Hmm.
about agents for agents and with A2A, and then tools for agents, which is MCP. And there are kind of like edge use cases where technically you could use an agent as a tool and have that be kind of
Yeah.
exposed via MCP. But overall, what I found is that A2A is better for those use cases. Actually, no. If you're using an agent as a tool, you may have good success. But if you intend to use an agent as an agent, which means stateful delegation, you
Yeah.
most of the time you want to use A2A because A2A has a lot of built-in measures for kind of enabling, polling for long agent responses
Yeah.
of that nature.
Yeah. Also, agent as a tool means, as you just you mentioned that agent has a state, but if you have using agent as a tool or MCP server, it's stateless, right? So it doesn't have the state control.
Exactly. Yeah. So again, so A2A complements MCP. They're not kind of competitive, and oftentimes in most production use cases, you tend to see a mixture of both of them being used. Um, yeah. So
Yeah.
that said,
I wonder before A2A, if I deploy my agent to cloud, then how do I communicate to the service I deployed?
oh, great question. Before A2A, again, there was no. I mean, there was different standards. There was things like ICP and, but the nice thing about A2A is it kind of creates a universal protocol for how
Yeah.
agents can communicate. But before A2A, we tended to see within each organization there was their own method of exposing agents, and it wasn't really universal. So, which kind of makes it less effective for different use cases, like a payment network agent,
Yeah.
where let's say you want to have an agent make payments for you and has to be able to communicate with some sort of consumer agent on another side. Again, you want to make sure that every agent across most organizations are using the same protocol.
Yeah. That's a great summary, and also that's exactly why we want to use A2A, right? I saw they're deployed.
Yeah, it's deployed. So our cloud build service worked. And if we
Let's
want
take
to
a look.
confirm that it worked, we can go over here to Cloud Run, and then we can go over here to Services, and you can actually see it there. But overall, so remember our Agent Verse dungeon. We're going to come to that later on in the lab. That's essentially where we're going to have the mini boss fight. So that's good to go.
Yeah.
We have the API tools on CP. We deployed that in day one. And then
Yeah.
now we have the earth familiar, the fire familiar, as well as the water familiar as new
Mhm.
endpoints that had been deployed. So now we have each of these familiar agents that are essentially, I believe, a parallel, a sequential, and loop deployed to their own Cloud Run service. So that's
Yeah.
great. So now that they're deployed to their own Cloud Run service, that now means they can be consumed as remote A2A agents. So that's the next step of our lab, is enabling our root agent, the coordinator, to essentially consume these remote agents as A2A remote agents. So let's see
Okay.
what that looks like.
I remember we have the orchestrator. So basically, it's a hierarchical routing pattern to connect to the summoner connect to them, right?
Exactly. Yes. Yeah. Yes.
Oh, yeah. I guess we have to first connect them.
Yeah. So that's the next step. So going to our summoner file, what we're now going to next add is essentially the remote A2A agent syntax for
Hmm.
connecting to a remote agent with ADK. So essentially, that syntax is essentially as simple as remote A2A agent.
Hmm.
Again, the same name that you provide for local agents, you have to provide that description of the agent, then the agent card. So essentially, you're going to be passing in the URL of where
Hmm.
that agent is deployed, and then the agent card well-known path is actually something that comes pre-packaged as part of like the A2A library.
Hmm.
So you don't specify it. It's kind of like a well-known path that's kind of
Yeah.
standard for all remote A2A agents. So
We're
that's
gonna see that later in our example, right?
exactly, yeah. So that's how other agents know where to find the agent card for each A2A compatible agent. So I'm now going to go to summoner / agent.py in the editor. So now navigating back to where we were.
Oh,
So
I don't see our terminal. Oh, I see it now.
yeah, so coming back over here, I'm going to make my screen a little bit bigger. I'm going to go
Please,
to the
can you
summoner.
zoom in? IO.
Yes, I
Thank you.
hopefully this is closer. So
Yes, a lot better.
agent.py, and there's still a few placeholders in our file that we want to essentially edit. So the
Yeah.
first thing we want to do is essentially define our remote A2A agents. So as I mentioned before, The ADK A2A package makes it really easy for us. All we're doing pretty much is importing the remote A2A agent class from the library. And again, we're importing the agent card well-known path from the library as well. So these are two things that we're going to be using as part of our definition. And then coming back over here, I'm going to copy this, as I mentioned before. And then coming back to the lab, I'm going to paste this here. So now we've just defined our remote A2A agents, one for fire, one for water, and one for earth. Lastly, or not lastly, but next, now that we've done that, we are ready for actually defining our root agent in the summoner. So let's take a look at that. So again, regardless if it's a remote agent or a local agent, there are a few definitions or parameters that you need to have as part of your agents. You have to have a name, so orchestrator agent, a model, Gemini 2.5 Flash. We're giving it a set of instructions. And then now we're passing in the remote A2A agents that we defined as sub-agents into our orchestrator or coordinator agent.
Yeah, see that. Yeah, this is like a broader pattern, right? So we have the orchestrator, like you can decide, okay, what is a familiar I want to delegate to? I can delegate to fire agent or water agent or earth agent, and I'm connecting them through those URL and understand when to use them and how to use them by reading that agent card. And we can also, like here we're using LM agent, we can also use a workflow agent like sequential agent or parallel agent here. And then also similarly, just if we can, as long as we can discover other agent server, like other agent through their agent card and their URL, and then we can also using workflow agent here to connecting them.
Exactly. That's a really good explanation in summary. So I'm going to go ahead and copy this here, and then come back to the cloud editor, and then make sure that here, and don't worry about this save last summon after tool. We're going to get callbacks later on.
Really soon.
Yeah, but and again, I like to always paste the code below the placeholder. Some people like to replace it, but I like to know where the placeholder was. So that's pretty much just the placeholder here. Yeah, that we're putting here. So root agents equals to this orchestrator agent. And then don't worry about A2A because it's ready. The code is ready there for that in this particular file. And that's pretty much it for this step. And then now, if we want to verify if things are working, let's think about what's happening behind the scenes. So I'm going to go back to the architecture of what we built. I'm going to switch to my slide. Give me 1 second to pull that up. So again, this is what we're building as part of this step of the lab. So far what we've done is create three A2A familiar agents, deployed it to Cloud Run. We've also now configured the summoner agent so that it consumes these A2A agents. And then now ideally, if we were to do ADK web, essentially, even though these agents are deployed to different services, they can still communicate as if they were in the same runtime. And that's what we're going to see in a second.
Okay. So we're going to test agent with ADK web.
With ADK web, which again is a development UI for ADK.
Yeah, for those of you who was not there yesterday, we also cover another way to run ADK is with ADK run. So basically, you can directly talk to agent in terminal, but with ADK web, you can see them in the interface. You can interact with them and troubleshooting in real time.
Yep. Okay, so now I'm going to go ahead and paste that ADK web command here.
Thanks for zooming in. I need my glass. So I see we install some requirement dependency over here, and then we start ADK web with this command.
And if things are working, if you recall, before we deployed the agents, these variables were blank.
Yeah. Now we have those URL because we have this remote A2A agent now.
Yep.
I'm curious. I really want to see the agent card. When can I see agent card?
It's coming up in a second. So we'll go through agent cards.
Okay.
Yeah.
Be patient, everyone.
Yeah.
Ayo, how would you describe yourself if you have an agent card? If you're an agent and you have an agent card.
That's a good question. I think, like as I mentioned before, I think agent cards are pretty much like the resumes for agents.
I mean, describe yourself.
Like the same way that you describe yourself on social media. So think about like an agent card being the Instagram for the Instagram page for Instagram profile for an agent. That's how I like to look at it. So I guess my social media is kind of like my agent card. But okay,
Oh,
so it deployed. Um,
IO skill coding agent
yeah,
AI expertise.
yeah. Okay, so again, if you want to open up the ADK web, you either click the link that comes up, where that's right here, or you can go to the top right corner and go to web preview and make sure that you match the port number with the 8000 port that was produced, and either one will kind of take you to the ADK web UI. Now that we're here, make sure that you select the agent you want to test. So right now we want
Okay.
to test the summoner agent.
Yep.
And so that will bring us here. I'm going to zoom in just so you can kind of see the prompt a little bit more. And let's go
Okay.
ahead and test it. So I'm going to present it with a monster and allow the summoner architect to essentially choose what familiar agent works best for that particular monster. Again,
Okay.
we're trying to train ourselves for the boss fight later on. So we want to make sure that our summoner agent chooses the right familiar to attack the right type of monster.
Sure. Let's see what summoner choose.
So I said hype. It's a single
Hi.
slow moving target with thick armor weakness, is inescapable reality.
What's familiar should they choose?
So you can see that here it transferred to the fire familiar. And then
Okay.
you see the delegation here. It delegated to the fire. And you can kind of see the input prompts, the output prompts. You can see that it was A2A facilitated. So it was through A2A message that was sent, as well as the outputs. You can also see the token counts for those of you that want to debug things like cost. It's all available through the ADK web, ADK tracing. But overall, it's working pretty well. So we
Okay.
gave it a hype monster, and it's using fire familiar for that. Let's try one more prompt as well. So if I were to give it another monster, let's see what it selects for that. So Dogma Apathy, a rigid stone-like inquisitor made of ancient rulebooks and enforced processes. Weakness is unbroken collaboration. So what comes to mind when you say unbroken collaboration?
Unbroken. Hmm. I don't know.
We'll see. We'll see what agent gets selected.
I yeah. Are you playing RPG game? I guess you have to play the game to know more strategy,
Yeah,
right?
yeah.
Are you one of those RPG game player? I
Um, I a little bit.
a little bit.
Yeah. So it looks like it's taking a little bit to generate the output, and we'll
Maybe
see
we
what
can
it
take a look
generates.
at the console to see the output.
All right, so we can see that the output got generated. From the
Mm-hmm.
fiery depths to the icy peaks, I gathered the scattered energies. So we can see that the orchestrator agent delegated to the water familiar. That kind of makes sense. Unbroken collaboration, and then it routed to the parallel agent um, familiar, which makes sense.
Mm-hmm.
Uh, and and it gave about 500 damage. So overall, it looks like our summoner agent knows how to fight monsters, and we're getting really prepared for the
Yeah.
boss fight coming up.
Yeah.
Yeah. And
What's next?
so what's actually, and for those of you that are following along, you can go ahead and test one last input. See if the Earth gets triggered. You should see
Mm-hmm.
the Earth familiar get triggered for this one. But since we already did two tests, um, actually let's go ahead and do it. And while that's waiting, I can actually show you an agent card example that Andy
Okay.
was just asking for. So
Can't wait.
yeah. So coming over here, we're going to say obfuscation, and ideally, again, elegant sufficiency. So what comes to
Mm-hmm.
mind when you think about that? I'm thinking loop agents, but overall, what you should see here is the Earth familiar get triggered. So it's taking some time because again, there's A2A communication happening behind the scenes.
Yeah.
It's delegating responses being generated. So it takes a few seconds. But while this is being generated, let me show you an example agent card for the same exact agent. So if you were
Okay.
to go to the Earth endpoint, familiar endpoint for this Cloud Run service,
Uh
so
huh.
again, all we're going to do here is come over here to the
Oh, by the way, we cannot see your tab.
Yeah.
Like we cannot see your. Oh, okay. Yeah.
Yeah, so
Thanks.
again, if you recall, so this is the deployed endpoint for the Earth Familiar. So this is
Hmm.
like the live HTTP endpoint. And remember we talked about the well-known path. So if you ever
Where
want to
is
find the
the
agent card
well-known
or
path?
deployed agent, yes,
Yeah.
just go to the endpoint and then go to .well dash
Oh,
known
I cannot
slash
see dot well dash
agent.json.
known.
So since I'm sharing my screen, you can't see it, but let me put it in the terminal so you can see exactly
Yes, please.
what I went to. So here's
Yes.
the URL that I went to. So again, it's just
Oh,
the
I don't see your terminal.
Oh, thank you for telling me. Thanks. So again, all I went to is the Earth Familiar deployed endpoint. So this is just like the base URL, and then and this is
Oh,
standard for all A2A dot well dash known slash agent.json, and that will then essentially show you the agentic JSON um, agent card for that agent. So here you can see
okay.
capabilities. I can see that it is the Earth Elemental Familiar. I can see the
Hmm.
workflows that it supports, such as the loop workflow. I can see the description. This agent will execute the charging agent, and so on. So essentially, these details are essentially the resume for this agent. And as I mentioned before,
Mm.
A2A also supports security schemes. So if I had supported things like OAuth or API keys, I would see that definition here. So other agents know that if I want to communicate with this agent, I have to first
Mm.
authenticate against it. So yeah. So essentially, this is
Mm.
like really good. And maybe let me pretty print it so it's easier to read. I should have done that earlier. But here you can kind of see a better, kind of clearer view of the agent card for this
Yeah,
particular agent.
that's really helpful. Thanks for showing us.
No problem. No problem. Yeah. So that said, let's go back to the output of the ADK web. So I can see that I'm the unyielding bedrock of the mountain's core. Let's see what got delegated to. The orchestrator selected the Earth Familiar. And again, you can see in the logs that it was facilitated via the A2A communication, the A2A request, and A2A response.
Hmm.
And there's multiple parts to the response. So again, that's some of the benefits of A2A, is that it's kind of optimized for that polling and multi-part output and input from these A2A agents.
Got
So
it.
yeah, so overall, everything is working. Our summoner is able to invoke each of our sub familiar agents and are ready for the next step.
Yeah, let's do. What's next step?
Yeah. So coming back over here to the lab, our next step is imposing the laws of magic, the interceptor pattern. And let me break
Oh.
you down what this means in a very simple way. So essentially, and to do that, I'm going to come back over here to the slides, and we're going to
Hmm.
now introduce the idea of callbacks.
Callback.
So
My
Annie,
favorite.
can you explain what like a callback is for like the audience? Like when would you use it? And let's start simple. What is it? A callback?
Yeah, so basically, agent has a life cycle. So agent has a model to decide what tool to use, and then like maybe pick a different tool, right? So before the agent start, before the agent start using the model, before the model is using the tool, and after the model is finished using a tool, I know after model decide, okay, picking another tool, and after the framework finish using another tool, and then like finally this agent like finish the whole process. So like at every part, like every point it's through this whole life cycle, you can intercept it and adding your own custom logic. And that is what we call callback. And as you can see on the screen, we have this before agent callback, before model callback, and after tool callback, after agent callback. So basically, you can add in your own custom logic there. For example, you can manage state or include guardian or adding control at specific point of this whole life cycle. And a good example, like IO had a really great lab about agent security with model armor. So basically, you can adding agent like a model armor to before agent callback to protect your agent. Maybe you can explain more, IO, on
Yeah,
that example.
that was a really great definition and explanation. Yeah, so as Andy mentioned, these callbacks are a great way of injecting custom logic at different points of the agent lifecycle. And you can do it for different reasons, such as security. Let's say you want to use something like Model Armor, which is Google Cloud
Maybe
Service.
we explain what is model armor.
Yeah, so Model Armor
Quickly.
is essentially like a callable API that you can use to filter inputs and outputs in general.
Yeah.
So you can imagine having an input, and before it being passed to the agent, you want to filter for any malicious inputs. So you pass it to Model Armor, and it would check for any sensitive data, any prompt injection, and so on. And if
Yeah.
there is detected there, essentially it will filter it out so the agent doesn't see it. Similarly, sometimes these agents can leak data that they're not supposed to. So again, you may want to have model armor after the agent is called and essentially check for any sensitive data there too. So you tend to see model armor used in these callbacks as well.
Yeah.
So overall, in this next step of the lab, what we're going to do is essentially design our own callback, but not for security
Wow.
per se, but it's to
Yeah.
essentially optimize efficiency of our models. And when we say
Okay.
efficiency, let's imagine that when these familiars get called, you want to make sure that essentially that their environment is ready for the next call before you call them again. You can
Yeah.
imagine a use case such as spam. You want to prevent someone
I
calling.
want to keep having attacked.
Yeah,
Same attack.
exactly.
Keep using the
You
same
want to make sure
attack.
that the agent is essentially cooling down and given enough time to kind of
Yeah.
respond to the next one and has the resources that it needs. So essentially, what we're going to do is inject our own callback that essentially checks to see when was the last time the agent was called. If it's
Mhm.
less than a certain amount of time, essentially it doesn't allow the call to go through,
Yeah.
and it blocks it. Otherwise, it allows the call to be called, the agent to be called. So essentially, this callback is essentially custom logic to just kind of look at the last time the agent was called and then do something based off of that.
Yeah.
Um, yeah. And then before we jump and move forward, there's also the idea of plugins in the ADK. And the thing about ADK is the global version of the callback. So for
Mhm.
callbacks, as you will see in the code, essentially you define it at the agent level. So I can
Yeah.
define a callback for one agent, but not for the other agent,
Yeah.
which can be good for customization. But let's say you want to have like a rule that's applied globally across all your agents. It's
Mhm.
simpler to sometimes just define one ADK plugin, which you then have it run against your entire ADK runtime. So all
Yeah.
agents get affected. So it's essentially think about plugins as the global version of callbacks.
Mm. I
Yeah.
see.
Any, do you tend
So,
to use callbacks more often or plugins in your applications?
I tend to use callback because oftentimes it's like, for example, you want to add a state control, so it's easier if you it's necessary that you adding callback to a specific agent to manage the state control, right? So
Yeah.
that's yeah.
Yeah.
Mhm.
Okay, so let's go through the code. So we just defined what callbacks and plugins were. So let's think
Mhm.
about what the code looks like. So essentially, you're creating a custom function. We're passing in a callback context. And again, this is SDK, ADK language or syntax. And
Mhm.
essentially, again, as I mentioned before, we're checking to see the last time that agent was called. If it's less than a certain amount of time, uh, you kind of implement your own cooldown logic and wait for it to cool
Mhm.
down. If it's more than that time has passed, then you allow the call to go through. And that's pretty much all we're doing here in the logic.
Um, yeah, I can see that in real life use case. One, like, we can use the similar check cooldown to prevent throttling the service, right?
Exactly. Yeah. So coming back over here to Earth Agent, that's going to be the first. That's where we're going to implement the callback or the cooldown period, and you're going to find the before agent function here, and
Okay.
we're going to define our callback. So again, check cooldown. We just want to see
Mhm.
the last time it was called and implement our own callback logic. So
Yeah.
that's what we're doing there. And then the next step, what we want to do is essentially add this before agent callback
To the
line to the Earth agent definition. So before
yeah.
we talk about there being different parameters that you can add to agents, we talked about name as one being a standard, model
Yeah.
being a standard. What's also available for these agents is callbacks. So let's
Mhm.
actually take a look at that now. So essentially, I'm now defining a before agent callback parameter that I'm adding to the loop agent. And if I wanted
Mhm.
to do after agent callback, it would be very simple. It would just be after
Mhm.
agent callback, and then I would add the same cooldown function if I wanted it to be, and so on. But
Yeah.
overall, all I care about for now is the before agent callback.
Sure.
Okay, so far what we've done so far is create the callback logic, and now we've passed it into the loop agent.
Great.
Now
I
let's go.
want to see. Does it actually have cooldown? I want to see how it works.
Yeah, so let's go ahead and do a quick test. So now we're
Uh
going
huh.
to go ahead and do the ADK run of our Earth
Yeah.
agent this time. So again, not ADK web. Again, when you do ADK run, you're essentially spinning up a kind of a terminal kind of command line interface
See.
for interacting with the
Let's
agent.
see. What does it look like?
Yeah. So coming back over here to the editor,
Mhm.
I'm going to come over here to the terminal again, and let me kind of exit out of that ADK web logging, And I'm going to go ahead and paste that. So ADK run earth, and it's going to, and again, so what I see here is gcloud. I caught it early. I probably should have let it go through. But again, if you see this error like gcloud is not authenticated, or you may see something like service account email is not logged in, that just means your terminal has lost authentication status, and you just have to refresh your browser.
Yeah, me too.
So I'm going to go ahead and refresh now, and that will
Yeah, it's a security. Yeah, it's for the security configuration that Cloud Shell will automatically expire after around 30 minutes or so.
Yeah. So now I just reran the same command, and this time you can see that gcloud is authenticated. So
yay!
And again, all these exported. That's because we ran the command this right here. We just want to make sure that since we were refreshing, we understand that people are going through the lab in multiple sessions. We want to make sure that you have all the environmental variables that you need. So each time we kind of have you source it. But that's the reason why it's taking a little bit longer. ADK run by itself is actually pretty quick, but we're kind of like doing a few things before that.
Yeah. So if we do a callback and also a plugin at the same time, does that work? For example, I have a callback in the before, after to callback, and then for the plugin, I have like before agent callback. If I do both, does that apply to both?
Yes, yeah. Yes, it applies to both.
Yeah.
So so again, you can define globally applied policies or logic through plugins, and then have individual callbacks through the callbacks that are applied directly to each agent. Okay.
That's cool.
So now that we have created that, let's go ahead and test it. So I'm going to say something like begin the seismic charge starting from 0. And what I should see get triggered behind the scenes is a few things being produced by the Earth agent familiar. So you can see that it's kicked off a few things, such as the ground trembles as seismic energy is absorbed. Again, it's going through the loop process that the loop agent has. And overall, what we've done so far is essentially invoke our Earth agent.
Yeah. And we're ready to spam our attack to test the cooldown feature.
Yeah.
Right?
And you can actually see that it's actually working already. So you can take a look at the logs, callback. It already checked to see if it was called within a certain amount of time. Obviously, since we've called it in a few minutes, it proceeded because we haven't called it back to back. But now that we just called it, I'm going to say the same thing again about 5 seconds later.
Quick. We're going to over the 1 minute window.
Yeah, so you can actually see that it says cooldown active for Earth Elemental Familiar terminating with message.
Yeah.
The Earth Elemental Familiar is exhausted and must recover its power. So you can see that now we've implemented our own throttling logic.
Can you try spam it and see?
Okay, we'll see if we can kind of break it.
Okay, I guess it's already past the 1 minute window.
Yeah, so the 1 minute passed as we were talking, but you can see that it did get blocked when we called it within that threshold period. So that's exactly what we want. So it's essentially just a good example of how you can implement your own custom logic and have it be implemented as part of the agent lifecycle. So people do this for logging sometimes. They do it for security, as we talked about before. So there's different reasons to have callbacks. Okay, so we can exit out of that and proceed with the next step of the lab.
What is next?
Okay, the next step of the lab is you can actually test the same thing with the ADK web. So you can actually do the same thing.
Optional?
But it's just optional. You just want more of a visual interface. Next thing that we're going to do is, rather than just defining cooldown just for the Earth agent, as mentioned before, plugins are a great way of globalizing logic across all of your agents. So again, if you have any organizational rules, define it as plugins rather than callbacks if you want that global effect. So now what we're going to do now is define that same cooldown, but as part of a plugin, and then we're going to add it as part of the runtime. Okay, so here's the cooldown plugin logic. You can see we're importing the base class from the ADK base plugin. We're defining our cooldown logic. And again, plugins essentially wrap individual callbacks. So essentially we're defining a new before agent callback that's part of the cooldown plugin class.
Yeah.
And we have the same kind of cooldown logic where we check the last time it was called. And yeah, that's pretty much it. So let's go ahead
and then we want to install this plugin to Runner so that you apply to all the agents. that's powered by this router, right?
Exactly, yes. So let's go ahead and define this cooldown plugin. So I'm going to
Okay,
come over here
let's.
to
Oh,
the code, and then we want to find the plugin file. So I'm going to zoom in so you can see it.
yes, please.
And then you just see this cooldown plugin file right here, and this placeholder replace plugin. So again,
Uh-huh.
the cooldown period is about 60 seconds. And if you want to change it, please feel free to. But I'm going
Yep.
to leave it at 60. And that's pretty much our cooldown plugin, where we have the plugin defined. We're importing, again, the base class from the ADK, defining our class level callback, and that's pretty much it.
Yeah.
Moving on from there, what we're next going to do is actually then pass that same plugin that we just defined into the runtime definition of our ADK runtime. But before we do that, we don't want to have two cooldowns for the Earth agent. So we're going to remove that individual callback that we defined for the Earth agent before. That was just a
Yeah.
demonstration of how callbacks work. So coming back
I
over here.
wonder if you have two, does that has 2 minutes cooldown then? Because
I
it was
guess
sugar tight.
that's
It's sugar
good.
tight, right?
Yeah, yeah. That's a good experiment for anyone who wants to test.
Yeah,
So go
please.
ahead and save it. So again, I commented out the for agent callback. Then I come back over here to the lab, and then I'm going to go to the agentverse architect agent to A2A.py file. Then I'm
Yeah.
going to go ahead and add this import. So let's go ahead and do that now.
Oh, I don't see your editor. I see your editor now.
Yep. Okay, so we just defined the location of our local cooldown plugin. We're importing the class. And the next thing that we want to do is essentially add that plugin to the plugins list for our ADK runtime. So I'm going to go ahead and copy this here and come back over here to the code and scroll down to the next placeholder right here. So again, here's our ADK runner. That kind of is the runtime definition of our service. So we have our artifact service for in-memory artifacts such as objects. We have our session service for maintaining actual kind of chat session memory. We have in-memory memory, which we'll talk about later for things such as like long-term memory or factual sentiments that we want to capture. But overall, this is our ADK runtimes definition, and we're adding plugins as part of that definition. So overall, now what we should see as the behavior of all our agents is that all agents will be affected by this cooldown plugin. So I'm going to go ahead and save that here and then zoom out. It looks like my screen froze, so I'm going to refresh. But let me make sure that I saved and then refresh now. And then now that we've defined our new ADK runner, let's go ahead and deploy our summoner to the cloud. But sorry, not deploy the summoner to the cloud. We're going to go ahead and rebuild all three agents. We want to make sure that they each have the, the plugin kind of in effect. So let's go ahead and do that now. And again, we're going to be using that same cloud build pipeline we talked about before, the image, the load to artifact registry, and then deploy to cloud run. So let's go ahead and run that here.
Oh, is that because in the agent to A2A file, we're changing the plugin so that we have to redeploy because we're using this agent to A2A in all the agent file? Because now I think we're using this agent to A2A to all the agent files so that we can have the remote agent, right? Because we're changing this.
Exactly. Yeah, that's a great point. Yeah. So even though we're working with remote agents, the ADK runner ensures that even when we're working with remote agents, they all have the same policies applied to them. So So again, this will take 2 to 3 minutes. And if you want to take a look at the cloud build logs, please just click the link, or you can come over here to the cloud build search, and you should see that it's building. It takes a few minutes. Right now it's queued, but we'll wait and we'll come back. Okay, it looks like our build finished. So now what we should have is our 3 familiar agents have now been redeployed, but this time they all have the plugin effect kind of enacted for all three of the familiar agents.
Yeah.
So come over here to Cloud Run, and just to double check that it kind of redeployed as expected.
Yeah.
You go to services, again, you can kind of see that this was last updated 2 minutes ago. So that's a really good sign that these agents were updated as expected. And now we can actually go ahead and test our summoner agent locally before we deploy the summoner agent finally to Cloud Run as well.
Okay.
Over here to the lab, after we've deployed and built the new agents, let's go ahead and run ADK run summoner so we can build up a terminal interface for interacting with the summoner agent. So coming back over here, I'm going to say paste ADK run summoner.
Oh, I don't see your terminal.
Thanks for letting me know. So, and so it's going to take a few seconds for the exports to kind of come into effect, as mentioned before. And then we can go ahead and test our summoner agent locally. And what we should expect to see is that whenever an agent gets delegated to, we just see the cooldown be enacted and checked. So, okay, let's go ahead and test it. So I'm going to say hype, and let's invoke hype again. And again, for hype, I believe it's fire that gets called. But overall, we should see the callback come into play. So we can see that let's zoom out.
Can you share the
screen?
Thank
you for letting me know. So what I just did was I called the same hype command that we ran in ADK Web before. And then I can see that, so hype is a single slow-moving target with thick armor weakness is an inescapable reality. Then I can see that a few things happened, and then the fire familiar was called. If I were to do the same thing, I should see the cooldown come into effect. The fire familiar is exhausted and must recover its power. So that's a really great sign. So again, we didn't define an individual callback, but we can see that the fact that we added it to the ADK runner itself is now affecting all agents within the runtime. We can do a quick other test to kind of confirm this and then move on.
Okay.
Say hype. No, I already did hype. Let's do a different one.
Okay.
I'm going to say, actually, we already tested it. So I think that's pretty much it. We confirmed that through fire, familiar.
It works.
So it works. So there's no need for us to, if you want to do it, you can try to invoke water or earth, but it works. So again, that's a really great example of how plugins work with the ADK.
Yeah, so what we covered so far is we cover A2A agent-to-agent protocol, and then in the A2A we have runner, right? So we install this plugin on the runner so that all the remote agent can inject this logic in their life cycle. And then before every time they start, they will check, okay, whether it's still in the cooldown period. If it's not, then it will just go ahead and continue. The agent will start using the tool. If it's within the cooldown period, then it will pause, right? So that's how we are. So that's we cover the A2A, we cover callback, we cover how to install plugin one so that you don't have to copy paste the same callback for all the agents that need the similar logic.
Yeah.
Great. So what's next, Io?
So let's move on to the final step of the lab before we get to the boss fight. So now we're going to be talking about agent state and memory. So we're now at part 8 of the lab. And what's the thing about what agent state and memory is? So Annie has some great labs about she's the memory guru. So Annie, can you please kind of, in your words, explain the difference between memory and state?
Hello.
And why it matters in context of an agent?
Yeah, sure. So agent memory is a very broader concept, right? But in this lab, in this scenario, when we talk about agent memory, it's the memory of our conversation, right? For example, if you're the agent, IO agent, I'm talking to you for the whole time, and then all the conversation it will store in the agent memory, right? And then the agent state is maybe I want to have some important information that I want to pass to another agent, or I want to remember. So I will have this dictionary with key value to it's a summary of our conversation. For example, we talk about coffee break. So we can say, like at this time, we have coffee break. That is a state we can store. And that state can pass from agent to tool and from agent to agent and also like, agent to agent and agent to tool.
Okay,
Right.
makes a lot of sense. So essentially, state is more concrete values. You're extracting
Exactly.
specific details from the conversation and saving it as part of like a scratch pad, like a dictionary. But memory is a little bit more semantic. It's more of like conversational, nuances that aren't really key value pairs, or more just sentiments that are extracted by, for example, an LLM and then stored in something like Vertex AI Memory Bank. Is that correct?
Yeah. You can essentially store either in memory, for example, that can store in the RAM, but every time you restart your server or you close your window, you lose all the conversation history. And you can also store in any type of database you like, for example, like Cloud SQL or more. Or you can store in Vortex AI, so that we have Vortex AI Memory Bank can have long-term memory, so that every time it will capture the summary of all the conversation stored in the memory bank on Vortex on the cloud. So every time we have conversation, it will always remember the previous context by retrieve memory from Vortex AI Memory Bank. So we have different type of solution for agent memory, and we can put the link of more reading here so that if folks are interested, you can take a look.
Yeah, okay. Yeah, absolutely. And great explanation. But diving back into the lab, so the reason why we talked about memory and state is that's what we're next going to do as part of this lab. So before we talk about callbacks as a way of injecting custom logic into the lifecycle of an agent. So before we created a before agent callback, and then we globalized it with a plugin. In this particular use case, what we're going to do is use an after tool callback. So not agent, but after tool callback. So whenever a tool gets called, we're going to remember the last familiar that was summoned. So remember, our summoner is summoning different familiars, earth, water, and fire, to kind of fight these different monsters. Before we call a monster, we actually want to remember or save the state what was last called. Whether it was a fire, was it water. So to do so, we're going to call the after tool callback to actually then interact with our state and then add new values to state.
Sure. Let's see how we are able to save that state and then put that in a specific callback.
Yeah, absolutely. So where we're going to do that is go to the summoner agent.py file. And all we're going to do is add a quick local function that takes as input a tool context as well as a tool. And then essentially what it's going to do, one thing that you can do with callback context as well as tool context is interact with state. So through tool context, we're going to interact with state and save a new variable called last summon, and then save a familiar name that was called. So essentially, we're going to prompt the summoner to extract or call this tool, this callback with the name of the tool that was called, and then save it to state. Yeah.
Let's do it.
Yeah. So that's the function definition here, and that's agent.py. Come back over here to the editor. I'm going to go over here to open editor. Let's go to summoner.agent.py.
Don't forget to zoom in, Yael.
I'm going to zoom in here. And then save last summon after tool. Again, it's just a simple function definition. And then again, all we're doing is, this line is the most important part, using tool context to access state and then add a new variable to state last summon. And we're saving the name.
Yeah, that state is a summary of, if you don't have the state, you have to pretty much go through all the conversation history and extract that important information. I mean, state, you just need to store things in that state so that, to have that to have that state in the context, and then so that you can communicate with agent to adding more custom logic. In this case, it's like we are having more. Yeah, we can have this logic in this callback.
Yep, exactly. And then lastly, similar to what we did before when we added a new callback for before agent, all we're going to do is go to the summoner agent definition and add a new parameter called after tool callback equals save last summon after tool. So down over here to the code. Yeah, so what are you going to say, Annie?
Yeah. So in this case, it's actually kind of interesting because, summoner agent when it's like a hierarchical routing pattern, right? So we have this root agent, we have the sub agent. So when the root agent is delegate to a sub agent, it's actually calling the tool like transfer to agent tool. So that's why here we're after it's delegate using that tool. So the root agent will use that tool to delegate to the sub agent,
Yeah,
and then so it's after that delegation, it will save this to the state. But that tool is not explicitly written here because it's implicit tool of this agent.
makes sense. Makes sense. That's a really good point. Yeah. Okay, so what we've now done is add that parameter to the summoner agent definition. And then lastly, what we want to do again is we want to kind of instruct it on, how to leverage the subagents and tools that we've now given it. So you are the master
Yeah.
summoner, a grand strategist who orchestrates your familiars. Your mission is
Yeah.
to analyze the description of a monster and defeat it by summoning, and so on. And you can kind of read the rest of the description if you're interested. But that's
Yep.
pretty much it. So
Let's
let's replace the
try it.
entire agent prompt with that, and be very careful. I know a lot of you sometimes like to change the quotes or anything, but you can leave these 3 quotes at the beginning and end and just change what's inside the middle. So I'm going to go ahead
Yeah.
and put that here, and okay, and we're good to go. So
Yeah.
master summoner, we have a new prompt for our summoner, and that's it. And coming back over here to the share tab, we now want to run it locally and make sure that everything's working. So let's go ahead and do that. So overall, let's think about what should happen now. When we're working with the agent, what we should see happen is that, again, cooldowns come into effect, as well as we are saving to state the last called familiar. So I'm going to go ahead and copy this, and let's see.
Let's see if it's remember what is the last familiar.
Yeah. So again, if you haven't used your terminal for some time, you may see
Oh,
this message. Just
I
make
don't see a terminal IO.
Thanks for letting me know. So again, if you haven't used your terminal for some time, you may see this message: your connection to Google Cloud was lost. Just click the reconnect button in the top right corner of the terminal, and then I'm going to zoom in so you can see. And I'm going to go ahead and run this here, the ADK run summoner that I mentioned before.
Yeah. Yay, this is user. You can input your prompt.
Yeah. So I'm going to go ahead and I accidentally clicked a button, but okay. Okay, hype again. And this is really good for us to see again. So even though I said reconnect, because I hadn't used the terminal for some time, I'm seeing this message, which essentially means that I have to re-authenticate in the terminal. And the best way to do that is just to refresh the browser.
Yeah.
So I refresh the browser, and I'm going to go ahead and do ADK run summoner one more time. So I'm going to go ahead and copy that command and run it.
All right. So I can see it is running. Let's quickly test it, IO.
Okay, let's test it. Okay, so I'm going to go ahead and put hype as a single slow-moving target with thick armor. And let's see what happened behind the scenes. Okay, we can see that saving last summon familiar transfer to agent. So that's the function that Annie was mentioning. And then we can actually see that it saved the state. Again, what we told it to save, agent name, fire familiar. So it called
Maybe you
fire
want to
familiar.
zoom in a little bit.
Sure. So it called fire familiar, and then it actually saved the state, this new value as part of the state dictionary. It's kind of hard to read here. With ADK Web, it would be slightly easier, but overall, this works all the same. So overall, you can see that it's working. So now we're saving things to our short-term memory scratchboard. And that's great. Okay, so that was the last step of the lab. So now that we've tested our summoner, it's working locally. We're going to deploy the summoner to the cloud and then do a boss fight in the cloud. Isn't that exciting, Annie?
Yay!
I'm excited, Annie.
Wait.
Okay.
Boss fight, please
Boss
deploy.
fight.
Deploy.
Okay, so let's go ahead and deploy and get this started. Okay, so again, as you know now, with Cloud Build Deploy, it takes a few seconds or a few minutes, but all we're going to do now is deploy our summoner agent to the cloud and then engage with the boss fight. And remember, our summoner agent is an A2A compatible agent. The dungeon or the boss is an A2A compatible agent. So really behind the scenes is all A2A facilitating this interaction and this fight. But we'll see that in a few minutes. Um,
Yeah.
and yeah. Okay, it looks like our agent finished deploying. If we want
Yeah.
to double check this, we can go over here to Cloud Run. I just
Mm-hmm.
happen to be in the Cloud Run area already. And
Mm-hmm.
I can see that we have a new summoner agent that's been deployed. So we have our 3 familiar agents as well as the summoner agent that's been deployed. And you see that this happened just now. So everything is looking great. So that's all looking great. So we deployed our orchestrator agent, we deployed our 3
So
agents, and now
is
we're
that
ready
time to
for
find
the
the boss?
boss fight. Okay, so let's
Yay!
get started with that.
I can't wait. I really want to see
Yeah.
the real fighting.
So coming over here to the boss fight, which is the last step before cleanup of the lab. And regarding cleanup, please feel free to do that at the end if you want to, or if you want to build on some of these architectures and continue, please feel free to. But again, going
Yeah.
back to the boss fight, what we want to do is echo our summoner agent path as well as the dungeon path. So let's go ahead and
Yeah.
do that. And
Don't see your terminal.
oh, thanks for letting me know. So here is the summoner agent path, and we'll do the same thing for the dungeon agent path. You don't necessarily have to do this. You can just go directly to the URLs in the Cloud Run dashboard, but this
Yeah.
is a quick way of doing it. And what you want to do once you do this is click the agent versus dungeon. When you click it, a new UI will be brought up.
Oh, so this is the battleground for us to to fight the boss.
Exactly. Yes, and what you want to do is click Crimson Creep, and then enter the dungeon. So let's go ahead and do that now. And I'm going to come over here and copy the summoner URL now. So copying summoner, come over here to the dungeon, and put the A2A endpoint, which is essentially the path of our summoner agent. And it automatically classifies it as summoner and dogma. So again, we just want to put the base URL. Don't worry about putting well-known path. All that is automatically handled for you. And then enter, and our fight begins. Start fight.
Wow.
Blindly follow the linter is salvation. We're fighting dogma. There's only one true framework, and it is the only one we've always used. That's pretty
I
dogmatic.
saw this is currently using the fire familiar, or is always using the fire familiar?
Oh no, so I think so for dogma, that's a great question. I think for dogma, it may choose one familiar more frequently than others, but I think it will still kind of decide which one makes the most sense.
Okay.
You will conform to the established architecture. Deviation is heresy. That's not how we do things here. So essentially, the boss fight is going to kind of give some dogmatic sayings, but then you should see some question and answer come up pretty quickly, and that's essentially how you submit your answer, and then that gets translated to an A2A communication that essentially has hit points, as we discussed before, and that's your boss fight. But it does take a few seconds, so we'll wait for Dogma to kind of stop talking. You know, all villains have a master speech, you know. Okay, it looks like our Dogma finished its master speech. And as mentioned before, here's our Q&A questions that we can answer. So in the workshop, why are the tools like the elemental fonts built as separate services? So to make sure all tools are in the same programming language, to make the project more complicated, so you can update a tool without having to change the main agent, to stop agents from using any tools. I always like the longest answer, so I think I'm going to go over to what do you think?
Yeah, maybe.
Oh, hey, it worked. 270.
I mean, you explain why.
Okay. So we deployed our tools separately. If you recall, our MCP servers separate from our agent definitions, and it's a good practice because you may want to update the tools without having to update the agents. So it's a really good kind of separation of principles. Yeah.
Cool. And let's see, what is the next question?
And again, Dogma always likes to talk. Doubt is a poison. A new library is a poison. Can you imagine? So again, we'll wait for Dogma to finish his evil speech. Okay, so time for the second question. What is the ADK web command used for?
Maybe a longest answer.
To check
longest one.
The longest one? Okay. to start a local test server with a user interface in your browser.
Yes.
I think that's correct.
Yay.
That
We
was
did
super
ADK
effective.
that quite often.
Okay.
We also have ADK run, right?
Oh yeah, ADK run, but remember ADK run is for the terminal interface. Okay.
Yeah.
144 points left to go. I think we can one more hit and we're good to go.
But our like health is like yellow.
I know, it looks like the dogma is kind of boring us to sleep. Okay, so one more hit and then we'll be good to go. The workshop uses a tool YAML file to create the database tools. Why is this a good approach?
Yeah, why is a good approach?
It makes the tools run slower but more securely. It's the only
No.
way to connect to a database. Now, we learned other ways
No.
as well. It's an easy way to define database tools without writing a lot of custom service.
Yeah, let's choose it quick. We're almost
Okay.
Yay!
We won. Victorious against Dogma. Okay, that was super fun. So let's kind of recap, Annie, what we built so far.
Yeah, so a quick recap start from part 1 to part 2. Like part 1, we talk about different type of MCP server, right? So the last question, we have this 2.2.yaml file that's actually from MCP toolbox. So we talk about how to use ADK to build custom MCP, and also we talk about how to using MCP toolbox with MCP. And then we connect the tool to ADK workflow agent. So that's including parallel agent, loop agent, and sequential agent. And once we connect the tool to the agent, we will orchestrate them together in the hierarchical pattern, but like we're connecting them through, we will first deploy them to like remote agent and then connect them through agent to agent protocol. So that's what we covered last time, like yesterday. And for today's session, we cover like everything, agent to agent protocol, agent communication, and also cover, for example, what is a callback, how to intercept certain logic for the all agent lifecycle. And then we also talk about the agent memory, what does agent memory mean, and why we're having the state, how does agent communicate to through state. And yeah, so eventually this is just like IO showing on the screen that we cover the whole picture from bottom, like different type of server, like MCP server for the tooling ecosystem. And then in the middle part, we cover like a domain workflow with agent part. And then at the very top, we orchestrate everything. So I hope that you inspire from this to build your own multi-agent system. And you can learn how to build your own tool, how to orchestrate everything, how to design your own agent design pattern, and how to connect them and leverage agent leverage custom logic in callback and using agent memory and more. Yeah, I hope you enjoy the session, and we're gonna cover more in next weekend. Thank you so much for those of you who tuned in today.
Thank you so
and
much.
Also,
yeah.
Yeah.
If you have any questions, leave it again comments in the chat. We're gonna answer all your questions and may even feature them next week as well. But until then, I'm Io.
I'm Annie.
And thank you. See you. Bye.
See you next week. Bye.